All right, I want you to do something for me. Close your eyes. There you go. Now, I want you to imagine yourself falling. Are you doing it? Great. Awesome. Now, speed up. Faster. Faster. You could go way faster this. Come on. Speed up. Great. Fantastic. Okay, now what I want you to do. Ooh, is that fire? Oh, oh, oh. You got to slow down. Stop. No. We're supposed to go this fast. What do you mean you can't slow down? You gotta slow down. You're compressing too much atmosphere. You're gonna blow us all up. You have no idea what you're doing. You gotta just stop. Is that Chelyabinsk, Russia? Oh no. Welcome back, number one, to Ty's one-on-one, where we're here to answer the question: are we safe from space? Space, 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 space. This one is complicated because it's hard to understand if you're safe from something that's not even on Earth. It's everything outside of the Earth's atmosphere. But that's not going to stop yours truly. No, no, it's not. So there's a lot that comes out of space. It's like basically the unknown frontier, right? Exactly. So to understand if we're actually safe from it, I believe that we need to just ask the question: are we really safe from anything coming from space and killing us? Such as asteroids, comets, and all that stuff. So basically, I took this question and broke it down into two other ones. One, do we see any Earth-ending space objects coming to destroy us now or in the future? And if we do see any, do we have a plan to stop it? I think that second question is pretty important. How about we begin with this first question? To be honest, no. There is no Earth-ending asteroids coming to kill us that we know of. You see, the way that NASA identifies moving objects in space is by taking a series of photos of the same area. They then compare these series of photos to see if any of the objects are moving. They predict the routes of these near-Earth asteroids, or NEAs, by keeping track of the movements over the course of years. I believe that there's a good amount of confidence here because NASA's been able to track 28,000 NEAs in space and been able to predict their paths for the next 100 years. Yeah, how do you explain the explosion that happened in Chelyabinsk, Russia in 2013? Oh, you mean that fiery streak that appeared in the morning sky to which anyone that saw it from inside their homes were blasted back due to the sheer force of this asteroid exploding in our atmosphere? Well, it would be hard to see anything when you have a big ball of light shining you right in the face. So let's imagine that this drop right here is the Chelyabinsk asteroid. Now I have a lamp set up back over here to which is reflecting light to this drop, which in turn is bouncing it off directly into the camera to you guys. So now look at what happens when I put the drop directly in front of the light. Now it's like I'm holding the tesseract in my hand. But yet it's completely saturated, yet it's still there. Here, I can even take it out. See? I mean, it's kind of cloudy. I don't exactly have a petri dish to be able to put this in, but you can see that that's the actual drop right there. That's the actual drop right there. Yet when I put it in the sun, you can barely see anything. It's because the light is completely saturating the dish that I have the drop in. And this is what happened with the Chelyabinsk asteroid. It came directly from the direction of the sun, making it impossible for us to see. And to tell you the truth, this is not up to scale. For me doing my research, this is not up to scale. The actual sun equivalent, if this is supposed to be if this right here is supposed to be the size of the Chelyabinsk asteroid, the equivalent sun is actually the Caspian Sea. So imagine trying to find a single drop in a body of water that stretches about 1,199 kilometers across. How is that even possible? The truth is, it's not. It's really difficult to be able to see stuff coming when it's from the direction of the sun. I think I just proved that point right here, right now. Now, the interesting thing is NASA was actually expecting an asteroid to come later that day. The asteroid's name is Duende. So imagine you're a scientist waking up to, there must have been a lot of questions. General, sir, in all due respect, Duende wasn't supposed to show up for like another 9 hours or so. Huh? It wasn't Duende. There's another asteroid? What? Oh, did we see it coming? I'm sorry, sir. I think the cell is breaking up. Well, that's our job. Wonder if the school district is hiring. Sorry, I make jokes when I can. But it's hard to keep track of objects 20 meters in diameter, which was the size of what the Chelyabinsk asteroid was. Especially if you're staring into a big ball of fire. And they can pack a wallop. 1,491 people have reported to have injuries after the event. However, 0 deaths actually have occurred. The injuries were more related to the shock wave generated when the asteroid blew up in our atmosphere. So there is potential that we might miss something due to factors we just simply can't measure. But it's highly unlikely we would be missing the Earth-ending asteroids. Okay, I think we've answered this question. How about we move on to the next one? So there is a plan to prevent asteroids from hitting the Earth. There is a team at NASA dedicating hundreds of hours to solve this particular problem. And they have came up with a plan. Step 1, hit it with a spacecraft. Step 2, that's it. There's just the one step. In November 2021, NASA launched the spacecraft DART with the sole intention of colliding with the asteroid Dimorphos. The intent of the project was to see if they could be able to affect the asteroid's orbit. So, the fate of the world is dependent on a nerd being able to toss a ball? Pretty much, yeah. Well, we humans had a great run. Hey, first of all, that's offensive. Second, we got a computer to do it. The spacecraft was allowed absolute control while it was making its impact run. This is when it utilized a series of algorithms the DART team developed called SmartNav. It's kind of the same principles that we use for missile guidance, and which the spacecraft was able to hit its target very accurately. They were able to shorten the orbit by 33 minutes. That's about a 4% difference. That kind of sounds a lot less than 100. Well, it's not on the scale of the universe. If we can catch an asteroid early enough and change its trajectory by 4%, we could turn an Armageddon into a Zuzin's comet. Speaking of Armageddon, that plan should not have worked. You do not do this to me, Ty. You know that's my favorite movie. You do not diss the Bruce Willis epic adventure. Look, I'm sorry, man, but there's just no way that they would know how the asteroid would break apart when they blew it up. Or if the explosion would provide enough force for the individual pieces to counteract their own gravity or Earth's gravity. It most likely would have come back together in a big, huge pile of rock and still crashed onto Earth. Or subject Earth to a meteor shower made up of the smaller pieces of that larger asteroid. La 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 la, not listening. La 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 la, not listening. Well, they kind of got one thing right. Do you remember why they decided to put the nuke inside the asteroid? Yeah, that's when you have a firecracker go off right here, that just burns your hand, but when you put it in like an enclosed fist, you have no more fist, right? Yeah, you know, it's more likely the opposite might have been better. No, no. I'm sorry, man. The current plan for dealing with larger asteroids, which is about 1,000 meters or above in diameter, is to detonate a nuke right next to it, hoping to change its trajectory. But still, the same consequences apply from Armageddon. But in this case, the likelihood that would happen is a meteor shower of smaller asteroids. But once again, it's going to be hard to miss 1,000 meter or above asteroid. So if there is one coming, we will probably have enough time to come up with a plan. All right, cool. I think that's it. Nailed that question. So, are we safe from space? I don't know. Look, space is an unknown landscape to which only a select few have been able to explore. And there's just a lot of unknowns that's hard to measure from just our planet. But there are agencies out there who are closing the gap, trying to understand what this universe is. And these agencies are full of people dedicated to doing research, gathering data, in order to find solutions for everyone to enjoy. And there's also the probability. Hey, give the probability of getting hit by an asteroid. What? It's 1 in 10,000, okay? You're more likely to get into a car accident than you are to be hit by an asteroid. See? Alright, that's all for today's video. I hope you enjoyed it, but if you have any questions, definitely leave them in the comment section below, and I'll do my best to answer them. Thank you for watching, and I'll see you around, number one.